Okay, this is about functions. And I think this is more like, well, this is to math as grammar is to creative writing. The rest of math, when we talk about transposition or square roots or whatever, that's more like vocabulary. This is more like the rules of how to say things. It's useful, so we're going to do this. A function, that's a name for a rule which takes an input called x, and from it calculates an output called f of x, f parent x and parent. So here's a picture of it. You start with x in this set of all possible inputs. F operates on it and yields f of x. The set of possible inputs is called the domain of f. The set of possible outputs is called the range of f. Here's some examples. X plus 17, this is the add 17 function. 23x, this is multiply by 23. X to the third, cubing function. 3 to the x, this is exponential base 3 function. Now we call the graph of a function the set of points with the coordinates x by f of x. So this y value, x by y, is equal to f of x. For example, here's an equation, y equals x squared. So that'll be the graph of the squaring function. Now, the thing to do is, well, here we make a table of x and y values. X will be various values, which we'll plug in, and get various values of it from y. So for x from -2, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So you plot those, -2 by 4, -1 by 1, 0 by 0, 1 by 1, 2 by 4. That's only 5 points. And really, I mean, mathematically, there's a continuous infinity of points. Now, a hand calculator will graph this sort of thing, and they'll use hundreds of points. Well, whatever. It's as fast as a machine. And if you do that, in fact, why don't I could graph it right now. X squared. Oh. And standard zoom. You get, oops, strange, just a second. 5. Strange. 6. Yeah. Can you see this? You get that U-shaped curve. This is a U-shaped curve called a parabola. You've actually seen it. It's the curve of the cable on a suspension bridge, for example. Or upside down, it's the curve of something flung through the air, free fall flight. So when you do so, you get this graph. I was speaking of a shorn kitty. Here's what he looks like. I guess I'm going to have to exile him soon. Whatever. Okay, hold on. Surest way to get him out of the room. Here, cat. This is what you're bugging me for, right? Yes, of course. Anyhow. So, equation, table of values, graph of them. Now, when you have a graph of a function, you can find its domain and its range. Here's a graph of a function. You project down onto the x-axis. That's the set of possible x values, which is the domain. Project onto the y-axis. That's the possible y values. That's the range. In this case, if you project onto the possible x values, you get all values of x. Any value can be squared. Here, if you project onto the y-axis, you get everything at least 0. So that's the range of the squaring function. Okay, excuse me. Get out of there. All right, cat. You've shown off your butt. Here, cat, this. One nice thing about cats is you can pick them up and toss them around. They don't actually mind that much. Well, they do, but not that much. Whereas a dog, no, it just doesn't seem right. Isn't that right?
Right.
They're more work, especially the bigger dogs. And they'd look at you, oh, why did you do that to me? Whereas a cat, ah, he's doing it again. All right, here we go. All right. If you have y equals f of x, then for any x value, there's only one y value, namely f of x. Therefore, if you draw a vertical line, which corresponds to a constant value of x, it will meet the graph at one point only, at most once. Here, for example, here's a graph of a function. Any vertical line meets it just once. It's a function graph. Here's a function graph. It's something called a logarithm. And vertical lines will meet it once. Some places it won't meet it at all, but that's okay. It's just that these negative values are not in the domain. Here, however, this is a graph of a circle, and it is not a graph of a function because this vertical line meets it twice. And this Z-shaped graph, it meets this vertical line 3 times, so it's not the graph of a function either. Now here are some function graphs. Y equals ax plus b. That's called a linear function because its graph is a straight line. Y equals ax squared plus bx plus c. Its graph is called a quadratic. It's a quadratic, and its graph is this U-shaped curve called a parabola. X cubed, y equals x cubed, has this N-shaped graph. Y equals 1 over x. It has this graph called a hyperbola. And if you've ever seen a lamp casting shadow on the wall, then if you turn this 45 degrees, you get the shadow of the wall. It's a hyperbola. Anyhow, and here the thing about this hyperbola is that it goes off to infinity this way, and this way, and this way, and this way, and it never reaches the line x equals 0 because 1 over 0 is outside of the domain. It's an infinity. And it never quite reaches the line y equals 0 because 1 over x is never 0 except when x is infinite. So the domain of this function is every value of x except 0. And the range is every value of y except 0. Here's a graph called the exponential, 2 to the power x. It starts very small and then becomes very big. If any vertical line meets, it can project onto the whole x-axis. So the real line is its domain. But if you look and project onto the y-axis, only positive numbers are in the range. Now here is a related graph called log base 2 of x, the logarithmic graph. It's actually related to this by flipping through the diagonal. You take this graph, flip the whole thing through the diagonal, and get this graph. And this means that these two functions, 2 to the x and log base 2, are what are called inverses. We'll deal with that later. All right, some examples. We're given a function. G of x equals x cubed minus x. Evaluate g at 1, g at 0, 10, g at negative 3, and g at 6. Well, you do so by substituting. G at 1 is 1 cubed minus 1. It's 1 minus 1 is 0. G of 10 is 10 cubed minus 10. That's 1,000 minus 10, or 990. G at negative 3 is negative 3 cubed minus negative 3. Negative 3 cubed is negative 27, minus a negative 3 is plus 3. They add up to negative 24. G at 6 is 6 cubed minus 6. That's 216 minus 6, or 210. Here's a related one. S of x equals the square of x plus 3. All right, evaluate s at 3, at negative 3, at 0, and at negative 5. S of 3 is 3 plus 3 squared. That's 6 squared, or 36. S of negative 3 is negative 3 plus 3 all squared. That's 0 all squared, which is 0. S of 0 is 0 plus 3 squared, which is 3 squared, which is 9. And S of negative 5 is negative 5 plus 3 square that. That's going to be negative 2 square that, which is 4. graph h of x equals negative x. Well, the absolute value function, it's this v-shaped function. Now, this negative means you flip up for down and you get this graph here. Okay, here, is this a graph of a function? On the board 4 times when I was in the room with people, people would be quick to answer. The answer is yes. Any vertical line hits it once, so it's yes, it's a function graph. Is this a graph of a function? No, because this vertical line meets the function line here and here twice, so no. Is this a graph of a function? This kind of a wiggly line? Yes. Every vertical line hits it at most once, so yes, it is a graph of a function. I do believe we're done for now. All right, let's say goodbye to the robot.